On June 30, 2026, every Shopify script still running in a live store simply stopped executing. Not degraded, not deprecated, with a warning stopped. For years, scripts were how merchants customized checkout, small Ruby snippets that ran on Shopify's servers to add a discount or change a shipping rate. Today we open the real source of what replaced them, Shopify Functions, and answer the question that matters more than the deadline: why does the replacement compile all the way down to WebAssembly instead of just running as more Ruby, or more JavaScript, in the same place scripts used to run? Welcome back to Shopify Development Deep Dive. Parts 1 through 8 stayed inside themes, liquid, JSON templates, sections, the CLI, the linter. Today we cross into the other half of the platform, backend extensibility. Shopify functions are how apps customize discounts, shipping, checkout validation, and payments, and they're the official, and now only, replacement for Shopify scripts. We're going to read a complete, real discount function written in Rust, the configuration file that compiles it, and the actual changelog entry that set the deprecation dates for scripts. 5 things by the end of this part. The real date Shopify script stopped working, straight from Shopify's own developer changelog. Why functions compile all the way to WebAssembly instead of running as an interpreted script the way scripts did. The real configuration file that wires a Rust function to a specific target, like product discounts or order discounts. How a complete, real discount function reads a shopping cart and decides which discount, if any, to apply. And the exact type result that function hands back, and what Shopify does with it once it's returned. Here's the whole path in 5 stages. A customer's cart or checkout state changes. Shopify runs the input query your function declared, gathering exactly the cart and discount data it asked for, nothing more. The compiled WebAssembly module executes, and critically, it runs inside Shopify's own infrastructure, not on a server you host. It returns a small set of typed operations, things like adding an order discount or a product discount. And Shopify applies those operations directly to checkout. There's no network round trip to an external server in that loop at all, which is the whole reason functions can run inside a checkout's tight time budget. A short list this time. Parts 1 through 8 of this series are not required functions or a genuinely separate system from themes, with its own tooling and its own deployment model. Basic familiarity with Rust syntax helps you follow along, but isn't required to follow the logic of what the code is deciding. If you want to build one yourself, you'll need a Shopify Partners account and a development store, both free to set up. And no prior experience with WebAssembly, or with the old Shopify script system, is required. We introduce what each one actually is as it comes up. These are the real dates, quoted directly from Shopify's own developer changelog, published April 9, 2026, and tagged under Functions, 2026-04. 2 separate deadlines, not one. April 15, editing and publishing new Shopify script stops being possible, existing ones keep running, but you can't create more. June 30, all Shopify scripts cease to execute entirely, no exceptions. That's the deadline behind this episode's opening line, and it's why every merchant still relying on scripts needed a functions migration plan well before this summer. This is the real configuration file from Shopify's own example discount function settings extension repository, and it answers a very direct question: how does a function know what to run, and when? The type is literally the word function. The targeting block names a specific target string purchase.product-discount.run and points at an input query file that declares exactly what cart data this function needs fetched for it. And the build command is real too, cargo.toml build, release mode. That single line is the entire compile step Rust source in, a WebAssembly binary out. This is the real Cargo.toml from Shopify's official function examples repository, and it's worth reading carefully. Functions can be written in Rust, in JavaScript, or in assembly script. Rust didn't replace those other options, it's simply Shopify's own recommended default for performance. This workspace files members pattern picks up every Rust example. The exclude list is what's interesting, it's explicitly excluding the JavaScript versions of the same discount and payment customization examples, because Cargo only knows how to build Rust crates. The JavaScript variants exist right alongside them in this same repository, just built with different tooling entirely. This is the real entry point of a complete discount function from Shopify's own discounts reference app. The Shopify _function attribute above the function is the whole integration surface. It's what turns an ordinary Rust function into something Shopify's runtime can call with typed input and expect typed output back. The first thing this particular function does is find the most expensive line in the cart, comparing each line's subtotal amount to find the maximum. That single cart line becomes the target for a product discount later in the function real business logic, not a stub. Before doing anything else, this real function checks which discount classes actually apply to this cart order level, product level, or neither. It reads that straight off the input's discount classes collection. And if neither class applies, it returns immediately with an empty operations list no discount, cleanly, in a single typed return. This matters because a single function can be configured to handle multiple discount types, and it needs to behave correctly even when Shopify calls it in a context where none of them apply to the current cart. When the order discount class does apply, this is the real operation. It builds an order discounts add operation, targeting the entire order subtotal rather than any single line. Notice this isn't hand-rolled math and a manually recalculated total. It's a typed candidate, with a percentage value of 10, and a customer-facing message, 10% off order, that Shopify itself renders in checkout. The function never touches money directly, it describes an intent, using types the platform defined, and Shopify's own checkout engine is what actually applies the discount to the real order total. This is where that most expensive cart line from step 4 gets used. When the product discount class applies, the function builds a second, separate operation, a product discounts add operation, and targets it specifically at that one cart line's identifier, by cloning its ID. The value is 20% this time, with its own message, 20% off product. So a single function call can return both an order level operation and a product level operation together, in the same operations list, each carrying its own independent target and value. Everything the function decided gets returned in one line, a single type result wrapping whatever operations list got built, whether that's 0, 1, or 2 operations. That's the entire contract between your Rust code and Shopify's checkout, read typed input, return typed operations, nothing else. And on the deployment side, this is the real build command from step 2 doing its job. Cargo.toml build, release mode, compiling that Rust source down to a WebAssembly binary that Shopify's own infrastructure can load and run, sandboxed, on every checkout that matches its target. A few things worth being careful about. Functions run inside a hard, small execution time budget, so keep the logic simple and be wary of unbounded loops over every cart line in a large order. The operations you return are intents, not direct writes to any database. Shopify's own checkout engine is what actually applies them, which is also what keeps every function's behavior consistent and safe across the whole platform. A function that finds no matching discount class must still return a valid, empty operations list, exactly like we saw in step 5, never an error. And always test locally against the real input shape your input query declares before deploying anything to a live checkout. Pulling it together. Shopify scripts stopped executing entirely on June 30, 2026, and Shopify Functions are the official, and now only, replacement. A real shopify.extension.toml file wires a specific target, an input query, and a Cargo.toml build command together into one deployable unit. A complete discount function reads which discount classes apply, finds the most expensive cart line when it needs one, and builds typed operations rather than doing math by hand. Order level and product level discounts are genuinely separate, independently targeted operations that can both come back from the same function call. And the whole reason any of this works inside checkout's tight time budget is that functions compile to WebAssembly and run inside Shopify's own infrastructure, with no external server call in the loop at all. That's the real story behind why Shopify Functions replaced Shopify scripts, a hard deadline, a compiled WebAssembly runtime, and a typed contract that hands intent to Shopify instead of doing the work itself. Part 10 goes further and builds a custom discount function from scratch in Rust, start to finish, in the Shopify CLI. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 10.